its effect. Now the second law is the mathematical definition of the force. Okay, the second law is basically the definition of the force. First law is the effect of the force. Second law
Okay.
is basically, it can be understood as the definition of the force. So let's understand, how do you actually define the force using the second law. So for that, I have to consider first of all the momentum, the concept of momentum. Now, what is momentum? So momentum, you will say that mass into velocity, yeah, but that again is the mathematical formula and not the definition, isn't it? Yeah.
Yeah.
We define momentum as the strength of motion. Is the strength of motion. It is basically a kind of uh, stress that the object is set into, and because of that stress, it is being moved. Okay, so
Okay.
how much stress it can bear. Okay, that's the thing. So it is basically, in simple words, like the word which I took right now to explain, that is like the Einstein's theory, but like let's go with the Newton's theory right now. It is simply the strength of motion. Okay, so the momentum is considered with the strength of motion. Now, how do you understand that like momentum is the strength of motion? So let's understand with this simple example. Let's say we have this uh, this belt, the path. Basically, this is a path. Okay, in front of
Okay.
your a kind of road. This is a road. Okay, and this is a private road owned by you. Let's say. Okay, this is the road which is owned by you. Now, you are not allowing anyone to go on this road. So, if suppose there is a biker, if there is a biker, if there is a bike, and the mass of the bike is here, the mass is, let's say, 100 kg, and its speed is let's say 5 kilometer per hour. Very, very low speed.
Okay.
Even walking speed is like 5 kilometer per hour. Okay, yeah. So the bike is approaching you with 5 kilometer per hour, and its mass is just 100 kg, and you don't want this bike to go on this road. Will you be able to stop him?
Okay. Uh, Momentum is mass times velocity.
Come on,
So
I
500.
haven't taught you the momentum formula. I'm just
Okay.
simply asking you the real scenario. Okay,
Probably
visualize.
not.
So you won't be able to stop him. He's going with the walking speed.
I think because it's quite heavy, I don't know if I'll be able to stop him.
No, you can definitely stop him. Like 100 kg is like not a good mass actually. Okay, for a
Okay.
bike, it is not a really good mass. Like you can kick him and he will be thrown off the road. Okay, yeah,
Okay.
yeah. So that's the thing. But like suppose, so basically, yes, it is possible to be stopped. Okay, you can definitely stop him. I'm giving you another scenario. Here, I'm having a heavy truck. Okay, and that is 1000 kg, and that is going with the 5 kilometer per hour. Will you be able to stop him?
No.
No. So here you can definitely stop, right? Here you can't
Yeah.
stop. I'm giving you the third scenario. Third scenario that here you have this bike, same bike, which was 100 kg, but this time this is going with a speed of 100 kilometer per hour. Tremendous speed. Okay. So will you be able to stop him? What do you think? Hello? 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 Yeah. So my question was, will you be able to stop him now?
I don't think so, no, because it's very fast and very heavy.
Definitely. Yeah. So you won't be able. See, the thing is, here you're not able to stop him because of greater mass. Okay,
Yeah,
greater mass. Here you are not able to stop him because of his greater velocity. Greater velocity, isn't it? Yeah. So the
correct.
point
Yeah,
is, that an object is having really good strength of its motion because of its mass and velocity. So here we are defining the momentum, which we are defining as the strength of motion. So the strength
okay,
of motion, which we are calling it as the momentum in this particular case, that is basically proportional to mass, proportional to the velocity. So we can definitely say
yeah,
that P is equals to mv. Okay, you getting it?
yeah,
Yeah.
yeah, yeah.
What should be the unit? Unit should be kilogram meter per second. That should be the
Yeah.
unit of this thing, right? Okay. All right. So we understood what is the momentum. Now, in the very beginning, when we were defining the force, we said that when you apply some kind of force, if it was going with velocity u, on application of the
Okay,
force, it can start moving with v. The thing is, from here to here, what has changed? What has changed is its momentum. Initial momentum over here is mu. Final momentum is mv, isn't
okay,
it? Now the thing
yeah,
is, if you are applying small amount of force, so this will take this change from mu to mv will take greater amount of time. But if the force is very high, if like you are applying great amount of force, then this change will take place quickly or later. Like it will take some time to change, or like it will happen like immediately. What do you think?
it'll take some time definitely.
So like when you apply greater amount of force, this change will be quick, or it will be delayed.
If you apply a greater force, I think it will be quicker.
Definitely it will be quicker, right? So that's the whole idea, that like here you are defining the force, you are defining the magnitude of the force, you are relating the magnitude of the force with the how fast it will be able to change the momentum. Okay. So and when for this particular change, when you are introducing the time, that means you are talking about the rate of change in this momentum. So what do we say? We can say that the rate of change in momentum, rate of change in momentum, that is actually proportional to the amount of force that you applied, right? The
Yeah,
rate of change in momentum is proportional to the force that you have applied. So we can say force is equals to change in momentum over time. Okay, you can
yeah.
simply write this as T. Okay, so we are defining the force as the change in momentum over time. Now, what is the change in momentum? Final
Mass times
momentum
velocity.
minus initial momentum over time. Yeah.
Yeah,
Final momentum is mv. Initial momentum is mu
mu.
over time.
Yeah,
Now, the same thing can be written as m into v
mv
minus u
minus
over
u.
t. Yeah. And what is v minus u over t?
That is displacement.
That's acceleration.
Acceleration, sorry. Yeah,
Yeah. So we got F is equals to ma. Yeah.
yeah,
This is that ma which is not letting you sleep. Okay.
yeah,
All right. So we got F is equals to ma. Yeah. So F is equals to ma. This is kilogram. The unit should be kilogram. And what is the unit of acceleration?
meters per second square.
Meter per second square. And this whole thing is actually known as Newton. Yeah. This unit is
Yeah,
also known as Newton. Okay. Now remember one thing, that since we defined force as the change in momentum over time. So basically, when you are showing the momentum versus time graph, okay, momentum versus time graph, then that the gradient is nothing but the force. Gradient is equal
okay,
to
okay.
the force applied. Okay.
Yeah.
Yeah. All right. One more thing. We can say that F is equals to delta P over delta T. Like that also. Like in a time interval, the change in momentum has taken place. That is basically because of this particular force. Okay. Like here you can consider this to be delta T, this to be delta P. So we can say force is equals to delta P over delta T. Yeah. So we can say this. Therefore, you can say that delta P is equals to F delta T. Do you agree?
Yeah.
Okay. So when you are plotting a graph of force versus time, then in a specific interval of time, let's say from here to here, okay, from here to here, whatever is this area coming out to be, this area gives you the change in momentum, delta P. Okay.
Okay.
Yeah. So delta P is equal to F delta T. This is also known as impulse. This particular thing, the change in momentum, is also known as impulse. Impulse mostly denoted by letter J. So do you understand this whole thing?
Yeah.
Sure.
Yeah. It's not that difficult. Yeah.
All right. Chalo, let's go ahead now. So basically, here, let's do a question. Suppose you are basically, you must have seen this kind of scooter that like
Yeah. I've seen the
the
scooter. Yeah.
person sits here and then he applies the force onto the ground. He he applies the force in the backward direction and then the scooter goes forward. Do you
Yeah.
agree? Yeah, you understand this,
Yes.
right? Now let's say that this whole system, the mass of this entire system is 30 kg. Okay? Yeah?
Yeah.
And its initial velocity u is equals to 15 meter per second. Okay.
Yeah.
Yeah, so this is the initial velocity 15 meter per second. Now when you are applying the force, you are applying some kind of force over here. Okay, and because of which it is being moved forward. Now what
Okay.
you are given a graph. Okay, here you are given a graph. This is force versus time graph. You applied a force of resultant force of for 3 Newton in the forward direction. This is basically the net force. So 3 Newton
Okay.
force. Whenever you are applying the force onto the ground, your resultant force is 3 Newton. When you are not applying the force, then there is 1 Newton, that is the negative 1 Newton, that is acting as the friction, which is slowing down the bike, which is slowing down this
Okay.
scooter.
I see.
Yeah. So this keeps happening like this. So basically, you are applying the force for 2 seconds and then you are not applying the force for next 2 seconds, like that. You getting it?
Yeah.
So basically, applied the force for these 2 seconds, then you are not applying the force for these 2 seconds. So in that case, it will be
Yeah.
slowed down. Then you are applying the force for next 2 seconds. Then you are not applying the force for next 2 seconds. Then you are applying the force for next 2 seconds. Then you are not applying the force for next 2 seconds.
Yeah.
Then you're applying the force for next 1 second. So I'm giving you till here. Okay. Yeah. You know that the speed at this particular point, u is equals to 15 meter per second. I want
Okay.
you to determine the speed at this particular point. Did you understand the question?
Yeah.
All right. Come on, do it. Get the value of v. See, what we did, we determined the positive area and the
Yeah.
negative area. So the total
Yeah.
area in this particular case, total area will be equals to 6 plus 6 plus 6 plus 3 minus 2 minus 2 minus 2. Okay. Sorry.
Yeah.
Wait a second. Plus the total area, negative area. So this area would be 6 3s are 18 plus 3 21. 21 minus 6, that is equals to 15.
15. Yeah.
1 5. What is this area? So this area is equals to the change in momentum because this is force
Yeah.
versus time graph. So this area is
Yeah.
change in momentum. So the change in momentum we got, that is equal to 15. So delta P, which is 15, that is equals to M into V minus U. Okay.
Yeah.
So 15 is equals to 30 into V is that we want to
We don't know.
determine minus 15. Correct?
Yeah.
Because U is 15. Yeah. So with that, we'll get the value of V. Sorry. So this is 15 over 30, that is 0.5 plus 15, so 15.5 meter per second. Done? Yeah,
Yeah.
you got it, right?
Yeah.
So easy way. Like I told you that like the area under force versus time graph, giving you the
Yeah.
change in momentum. So you should have directly used that formula. Okay. Anyways,
Yeah.
let's go ahead. So now the next thing that we have over here is okay. So the next thing that we have over here is a free body diagram. Now to understand the free body diagram, and this is the most important part. Okay, to understand the free body diagram, you're supposed to know the different types of forces. So let's understand the different types of forces. If I'm talking about the fundamental forces, so the fundamental forces are of four types: G, W, E, N. Gravitational, weak force, electromagnetic force, and the nuclear force. So these are the fundamental forces. We are not talking about these fundamental forces. Okay, we are learning the classical mechanics. So in the classical mechanics, we are having like few forces which we'll be working on. We will be working on, and those are basically the weight, the tension in the string, then normal reaction, and finally the friction. So these are things on which we'll be working. Yeah. So let's talk about the very first one of these, and that is the weight. What is weight? Weight is obviously the gravitational force. Yeah. So remember one thing.
Yeah.
Yeah. So remember one thing, that weight is basically defined as the gravitational force. Weight is equals to mg. Okay. And it is always directed vertically downward. Always vertically downward. Always
Yeah.
vertically downward. Okay. What does that mean? So
Point
basically,
straight down.
yeah. So basically, if this is the object, so in this direction, it will be having the weight. If I'm considering an object tied with a string, so this is the direction of its weight. Okay.
Yeah.
Yeah. So if it is at some angle like this, so this is the direction of its weight. You getting? So always it is vertically downward. Yeah. Okay.
Yes.
Now this is the first type of force. Even if it is on the like some kind of inclined plane, let's say like this. So over here also the weight is vertically downward. So you should not get confused where the weight should be acting. It is always vertically downward. The second
Yeah.
type of force that we have over here is the tension. Tension in the string. Remember, this is always possible only in the stretched string. Only in stretched string. Okay. If it is not stretched, if not stretched, then in that case, the tension is equals to 0. Okay. The second thing, the second thing that you're supposed to know here in the tension, that it is always acting towards the fixed end of the string. It is
Yeah.
always acting towards fixed end of the string. What does that mean? That if
Where it is attached.
where it is attached, yeah, this is the fixed end. This is the movable end. Yeah. So this is the fixed end. So tension is always along the string towards the fixed end of the string, and always along the string. Along the string. Like suppose if it is like this. So this is the fixed end. This is a fixed end. And the tension will be acting like this, which is along the string and towards the fixed end. You got it, right? If it is slack, so what is the tension over here?
0. There is, because there's no slack.
Yeah. All right, let's go ahead now. So the third thing that we have over here is the normal reaction. Now, to understand the normal reaction, I want you to know the Newton's third law of motion. What is Newton's third law? Newton's third law says that, like, of every action there is an equivalent opposite reaction. Okay, like suppose when you are keeping the block on the table, when you are putting the block on this table, so this block is applying some kind of force downward. Okay, it can be because of its weight, it can be because of some external force. So this is the action force. This is the action force by block on the table, on table. It can be because of its weight or some external force, Okay, now do you think if the table doesn't break, that means table is applying an opposite force in exactly in the opposite direction to balance this block? Okay, so this is known as the normal reaction. This is the normal reaction which is happening if the table doesn't break. The table doesn't break. You're getting it? If it cannot be penetrated by the block. So this normal reaction is this is by the table on the block. By the table on the block. Okay. So you can see we have action force and then we have the normal reaction. What does this normal reaction mean? That it is perpendicular to the surface. Normal word means perpendicular. Okay, you got it, right?
Yeah.
Like for example, this is the wall. Let's say this is the wall. Now this is the block. And by some force, like some external force, we are applying some force onto this object. So because of this force, it can be moved further and it can be kept stuck to the wall. It can be kept stuck to the wall. You're getting it, right? Yeah. So it is having, this force is having two components. One component which is moving it, another component which is keeping it stuck to the wall. So the force which is being applied on the wall by the block is this particular component. Let's say FH. FH means F horizontal, F vertical means like going upward. So this F is resolved in FV and FH. Okay.
Yeah.
So there will be a normal reaction which is by the wall on the block in the perpendicular direction. Okay, perpendicular to the surface. Okay. And this value, this is basically known as the normal reaction R, which is equal to the FH, which is equal to the action force. This is the action force. Yeah. So what is the normal reaction? Normal reaction is always perpendicular to the surface. And second thing, it is always equal to the action force in opposite direction. You got it, right?
Yes.
And the last force that we have is the friction, and that's the fourth force which we are supposed to know the classical mechanics entirely. Yeah. Okay. Wait a second. All right. So that's the last thing. So the last force that we are covering right now is the friction. So what is friction? Friction is basically opposed to the motion. It is an opposed to the motion with respect to surface. So if the block is moving in this particular direction with respect to the surface, So there will be a friction acting in this opposite direction, which is basically kind of resistance to the motion. Yeah, you getting
Yeah.
it? So it's a friction. Always friction is equals to mu into r, a constant into r, where r is the normal
The
reaction.
normal force.
Yeah, yeah. So and mu is the coefficient of friction. Mu is the coefficient of friction. Okay. Yeah. So I hope this is clear to you. Yeah.
Yes.
If it is not in contact with the surface, there will be no normal reaction. There is no friction. Clear, right?
Yes.
Okay. All right. So we are done with all the types of forces.